Hi Year 11s, we're doing a video this week on doing science right, because I'm not there in person. So this is the PowerPoint presentation we're looking at in week 11 of term 1, preventing infection. So let's begin. We're going to start by talking about specific immunity. So specific immunity may be something that's acquired passively or actively by natural or artificial means. When we're talking about naturally acquired specific immunity, so naturally acquired specific immunity, that's acquired actively through the immune system responding to a specific pathogen that's entered the body. Whereas naturally acquired specific immunity, it can also be acquired passively through the transfer of antibodies from one host to another. So this could be a mother passing antibodies to a fetus through placenta, or to a newborn through mammary glands and milk. On the other hand, artificially acquired specific immunity, this can be acquired actively by intentionally exposing a foreign material that initiates a specific immune system, so vaccines, or it can be artificially acquired specific immunity, which is acquired passively through the addition of antibodies or lymphocytes that are introduced through a host. So, for examples there, we're talking about antivenin. So, one of those things that we talked about before, so going back over here, artificially acquired specific immunity acquired actively is vaccines. Talking about vaccines, vaccines stimulate the production of antibodies and lymphocyte memory cells against a given pathogen without causing illness. Now that's generally because they contain one of the following things: either an inactive form of the pathogen that's killed through heat, a less active form of the pathogen that's less likely to cause disease, antigens that have been isolated from their pathogen, or an inactive form of the toxin that is released by the targeted pathogen. In terms of the new COVID vaccines, we're looking at just a strand of mRNA coding that actually makes the protein or the antigen that the pathogen would create. But how does a vaccine work? To start with, they initiate your primary immune response that you would get for that pathogen, and it kills. That primary immune response's job is to kill the pathogen that's found in the vaccine. When they do this, they create memory T and B cells, and then when the patient is basically exposed to the pathogen again, you'll get a secondary response. Now, the secondary response is much more rapid and much more effective, so you don't get sick or as sick. There are some vaccines that will protect individuals for life, others require boosters. A booster is just an extra dose of vaccine that's administered after your first dose. Examples: tetanus shots are given every 10 years because the memory B and T cells that recognise tetanus, they would have died out if you're not exposed to that virus within the 10 years. Herd immunity. So this is if no one is vaccinated, an infectious disease could spread rapidly and cause disease in a large number of individuals. If some of the population is vaccinated, the disease will still spread and it will affect those that don't have immunity. Herd immunity is when we describe a population that's got a majority of the population vaccinated or have had the pathogen. And when they're vaccinated, they prevent the disease from spreading and therefore protecting those without immunity. One more little video we'll watch on vaccines. I won't play it in this video, but I'll put it on Doing Science Right for you to watch.